Welcome to this 15th session of Ergonomics for Beginners Industrial Design Perspective. Today, we are going to start module number 4, that is posture and movement. Under this module, there are total 8 sessions. These 8 sessions are this class number 14, human body structure and function. Class number 16 would be posture and job relation. Next, class number 17, posture and body supportive devices. Class 18 would be chair characteristics. Class 19, vertical work surface. Class 20, that is horizontal work surfaces. Class 11 will concentrate on human movement and their design relevance, and class 22nd would be work counter. Now, with this, so today if we consider the natural position and awkward posture, the activity or task should scope a coordinated balance among body parts or body as a whole as close as possible to the natural position, so that ergonomic risk association with the task would be minimized. Now, what is the neutral position? Neutral position, we can say that if a man stand or sit, his total body weight will be distributed evenly and there will be no stress or pain feeling on the body. So, that we can say the neutral position. But for any kind of activity, even during leisure time also, we adopt various posture, and some of the posture it affects negatively on our health and performance. That we call a awkward posture. Now, if we understand the factors behind this, then we can work upon accordingly, we can design. Now, what is the ergonomic risk factor? Now, everyone wants a safe and healthy product and workplace to work with, but we do not achieve this and vary a great deal. Means what we do to achieve this vary a great deal. Now, if we consider this ergonomics risk factors and ergonomics risk, we can compare with the fire triangle. This fire triangle, we can say that the 3 arms heat, fuel and oxygen. If we can reduce the intensity of any one or the intensity in combination, it will reduce the effect. Means if we reduce the heat or the fuel supply or the oxygen availability, it reduces the fire hazards. In a similar way, the ergonomic risk at any work or at leisure period, it can be by postural adaptation, what type of posture he adapts, then force, with that posture what type of force he applies, how long he applies, and the frequency of that posture adoption and the duration of that posture and the force application frequency. These 3 work together and give this triangle of ergonomic risk factors. If any one is out, it would minimize the risk. Now, in today's discussion, we are concentrating on the posture. How handling this posture we can reduce the ergonomics risk factor. Now, what is the posture? The posture is often imposed by the task or the workplace design. The prolonged posture can in time lead to complaints of the muscles and joints. In this class today, we would take a journey on body axis specifically and the natural position. Now, what are the normal body axis we have and how we work, how we apply force, and what are the normal axis of body movement that if we follow, it will exert the desired force and effect. Now, if we see this figure here, the person, we can see the person is working in a lock manufacturing factory, where he has to give a pressure, means he has to operate this control, as well as he has to work here, and to operate this. Now, all the people you can see that this posture is not, by seeing looking it appears it is not a good posture, but this type of posture it demands the work. So, what can be done? Can we do something on this design of the machine, the workplace, the method of work, so that a person can work according to his normal body axis movement? Now, here he is sitting there looking at this side and this side, operating here, at the same time with a sideways he is operating this. So, sideways operation of the lateral positioning of the leg is not the natural position. So, what can be done in this case? This is a matter of study field. Now, another figure we can see here, that while working in this, now see the person how he is operating. So many things he has to operate with the body. Here also the handle is provided here for his ease of operation, but the position he is sitting here, whether it scopes for a good study, whether we can increase the height of this work table, or we can modify this design of the machine, so that the person can sit properly and can exert all the force requirement, or the area he needs to work with skillful movement can be performed through the normal body axis movement, and that would be close to the neutral posture. Now, what is the posture definition then? Now, there are many definitions and context specific explanations about describing posture from various angles of views and concerns. It can be said that a body position, when we adopt for certain task or in rest and leisure should not create any uneasy feeling and impose any additional physiological load and strain. That would be a good posture. Now, if we see this hand and arm postures, the posture may be as a whole body posture, how we adapt for certain task, or in specific part of body to do a certain task, how it behaves naturally and what would be the work tool to support that or go along with that posture. Now, here we are showing some of the work item like this way. While holding this drill machine, the arm position is in a different angle. So, this is not the natural holding. So, if we want to hold something, this is the normal holding position, and with this holding position it can be said that from this angle and this straight angle, it is around 13 to 19 or around 20 degree angle in between. So, if we want to hold something in a horizontal way, so the wrist has to bend, but if we try to make the equipment like this way, then either we can hold it like this way or we can hold like this way. So, these are the some method of matter. In this case, in this holding is not correct, because here the angle of bending is there, but in this case if we hold it, it may be good. Now, holding in this area also has some bend, but here this hold is okay. So, here what is happening, without changing the equipment, the holding pattern if we use correctly, then we can get a good result. Now, select the right type of tool. When using handheld tools, the wrist should be kept as straight as possible. Now, these are the some of the examples shown here. Accordingly, if we see that, suppose another we can say, do not bend the wrist, use carved tools instead. Means while operating, if we see this figure, while operating it, when one arm is holding here, the another arm is holding here and with a bend and an angle. So, instead that if we can have this handle, this turn like this way, then it is the normal holding. So, it will be better to work with it. Now, another thing is that for a normal pliers, if we have to exert the resultant work here, the holding of hand is like this, and here what happens, the angle takes place. Now, if only handle area, holding area, if we can bend, then holding will be easier, but resultant effect will be at the same level. In this small hammer, in the straight handle, this is the angle, and if we bend only this, then it will be straight. So, only holding easiness here, but resultant effect for the both remains same. So, correct location of hand grips on tools avoids having to bend the wrist. So, here we can see that normal axis of holding matter. Now, another topic we can say that lessen the static load. Now, here the three sets of examples are provided. Now, see the top right corner example. If we want to operate something at the back of the body, then it is difficult. But our body structure is in such a way that it is better to operate in the front and then side. But in this case also it is said that if we keep any operable handle or switch at the center of the body, and if we expect that we can operate like this way, it is difficult, because our normal body this distance, and if we extend our arm from the center, it takes around 15 to 30 degree angle. So, at that area position, the handles if it is kept, then it will be easier to operate than the straight one. So, here it can be said that avoid carrying out tasks requiring elbow at above shoulder level. Also, above shoulder level some work should not be done, because to maintain this position over shoulder, we have to spend some energy here, and it also provides a static load on this arm. Normally, arm natural position is that hanging down. So, it will be better to position certain activity area below the shoulder level. Another example, at the left hand bottom corner, avoid working with the hands behind the body. And another example, we can say the center is that while operating or holding some heavy equipment, in this case it is a drill machine kind of thing, if we have to operate, then hand held tools must not be too heavy, should not increase 2 kg if cannot be rested on surface. We cannot hold more than this weight for a longer time. In this case, if he is operating and the assembly belt is here, in the assembly belt where some items are passing and he has to operate on it, then when he is operating this object, it can be hanged with a spring kind of thing, so that when he needs to operate, he can hold it and operate, and in between the gap, just when he is waiting for next one to come here, the front, he can release this, it can be remain hanged on this, so he can get relief. So, like that heavy tools, so it can be said that heavy tools for frequently use can be suspended on a counterweight. Now, in a very common and layman's understanding, what we can say, earlier we said that the working posture should be such that it should not affect negatively on the health. But then what is the health? It can be said that the body position should not affect health. What is healthy condition then? Again, many definitions and clarifications are available from various viewpoints and concerns. We can say from ergonomic design point of views that when we feel presence of any body part or the body as a whole, we are ill by that body part or in totality. We need to either take a anticipation of a preventive step in advance or take clinical approach through various means. means we can say that if there is any ill feeling on body, the current set of discussion focuses with the posture, that is the adopted body position and its good practice relevances. Then if we try to understand this feel presence ill by ill, that body part etc. how? Suppose when we are sitting, we are not feeling the presence of our head or palm, finger or anything. Now, if I do not feel any problem of back at this moment, but if I sit for quite longer time here, then I may feel pain at back, means I am feeling presence of my back, means I am ill by that position, that part. So, why then look into the facts or factors why it pains, then we can find out the design dimension of the chair matter, it matters, and then accordingly design something like that. While writing something, at the beginning I am not feeling any problem, but after few minutes I may feel pain in this fingertips, because while writing with anxiety I gradually go on increasing the pressure on this pen with these fingers, then it starts paining. Then I am ill by this portion, this part. Why it happens? Means holding may not be good. If I can change my holding pattern position, then the muscles responsible for holding it may get relaxed after sharing their load to other group of muscles etc. like that way. So, then accordingly design the pen so that it gives a chance to change the positions. So, by this the good practice relevances can be designed. Now, with this there are some items it can be said that like body planes. Now, while mentioning that making a workplace or something, we can say that which area or of my body, this is the central body axis through head to the toe point to the heel point straight. So, which side, left, right, front side, back side, up, down, bottom part, middle part, how to express the positions, for that the body planes are there. These descriptions. The bilateral human body could be described in terms of three reference planes in relation to the three planes of directional motions corresponding to these reference planes. Now, here the body, we can say that the first one division like this we can break, we can cut it. So, it makes a front side and back side. So, this plane is called coronal or frontal or lateral plane. If we make a body part right side and left side, and in between if we frontally if we break it, cut it like this, so this plane, it is sagittal or anterior posterior or median plane, it is named. Anterior means frontal, posterior is a back side. And another is that if we cut in the transverse way, the top and bottom part, this is the transverse plane. Accordingly, we can say that which position, either this position or this position, we can name it. Means the bilateral human body is described in terms of three reference plane to describe various location and dimensional motion corresponding to body position. These imaginary planes are used for the identification of relationship between the positions of things and the postural configuration and for description of any location. For example, it could be said that while standing and attentively working in an upper anterior medial plane, upper anterior front side medial plane, it is not possible to reach for anything kept in the location of the lower posterior plane very near to the floor, without distracting the attention of the central work area. Like that way it is normally described. Now, the human natural movement axis. Now, we are going to discuss normal movement ranges at joints or the normal ranges. If any movement or force to be applied either using a part or the whole article, the direction for force application should go with the configuration of the human body, that is, it should synchronize with the human natural movement axis, so that maximum mechanical advantage could be achieved. Now, if a man stands like this way, head till 40° angle it can rotate, like this 40° and 40° like this. Body, the whole upper trunk at the middle point, midpoint at the lumbar point, it can bend 40° and 40°. So, total 80° it can bend. Leg at hip can bend 40 inner side, medial side, and outer side, the lateral side around 45°, the leg can extend. At knee, knee can bend inner side 50° and lateral medial side 50° and lateral side 20°. And the foot here from heel point, from the heel joint, inner side 45° and outer side 90°. So, means 90° with shank rotation, shank means lower leg, 10° at a fixed shank. And here also 45° with shank rotation and 15° at a fixed shank, means fixed lower leg. If you lower leg is fixed, then it can go maximum, or with like this way it can bend it. Now, from the side profile, head can bend front and back 30°, front 45° head flexion. At the lumbar area, front it can bend lumbar flexion 40° and lumbar extension 10° back side. At hip extension, back side 20°, hip medial side, frontal side 70°, and leg at hip back, leg can go, standing leg can go maximum back side 45° and front normally at around 90°. 90° leg one can extend like this way. Knee flexion and the sitting position 90°, and to assist raise, this leg can come little back, and so it becomes around 80°, and squatting it is 25°. Here up 40° and down 45°. So, these are the normal body movement ranges, normal ranges. So, for designing for mass use, when we do not know who will be the intended users, these ranges should be considered. Now, another thing is that the arm movement, if we like this way and then if we do the arm movement, the inward movement is called adduction and outward movement, the lateral side is the abduction. So, adduction with a fixed point, it can come till 45 degree normally with the arm hanging down vertically like this 45 degree, because it gets stuck here, and outer side it may go maximum 90 degree like that, but beyond that it cannot go. Now, head rotation means like this way, head rotation is possible around both the left side and right side are the 45 degree. Now, the shoulder rotation will be around 35 degree from the horizontal position, 35 degree. Then arm at elbow point, 55 degree and below till 90 degree. Here hyperextension at back, the arm, if it goes back and 45 degree, 90 degree, 90 degree and vertically it can go till 180 degree. Now, here what has happened, the whole arm movement over the head, it is around 360 degree, one can move the arm. Now, the palm rotation, deviation, etc. Palm outer side 40 degree, that is ulnar side, and medial side or radial side, inner side is at 30 degree we can bend. Now, palm extension upward 65 degree, lower 80 degree flexion. The fist pronation and supination like that, here around 90 degree one can, means arm can go like this way and can go like this way from this position 90 degree, 90 degree. So, if I have to hold something design, but if I want to work this distance, then it should be within this range, it cannot go beyond. These are the normal body axis movement and the ranges of joint movement. Now, if we see some of the figures here again, that it gives reaches and the frontal work area. When we are holding a paper cutter, it has to be held like this way, and if it remains straight, then we can exert skillful movement. But if I want to cut something in this region like this way with this sweeping movement, it may not give that clear or that skillful activity, because the equipment, the blade is concerned, it does not allow to work this way, it allows to work like this way. Now, again something, see the handle position. This area is a inner side is the bathroom and outer side is the main room. So, the door itself, here the handles put in a little diagonal way, not as a horizontal or vertical, because it will be easier to hold. We cannot hold like this, we cannot hold like this. It is better to have a 45 degree angle at this position. So, if it gives that flexibility. In this case, the handle here and the person moves frontal movement. So, this also works accordingly. If the person frontal movement here, but if this handle is in sideways, then that movement would have been difficult. So, the design should go along with the normal body axis movement. Now, movement and force application push pull. This type of products either to be pulled or pushed. This type of product it requires mostly the pushing force with the mechanical and electrical assistances. In this case, pure manual pushing would be little difficult, because if you pull, the normal physics rules it helps, pushing would be difficult. This type of trolley it may be pushed and pulled. This type of chair push, pull and total rotation. Now, what is the fallacy? The main matter here is that suppose a trolley it has 4 wheels. Now, if we want to have a clear direction, then either front wheels or the rear wheel should have the swivel movement. If all the 4 legs have swivel wheels, then there may not be proper direction. So, in the normal the trolleys are used, mostly the front wheels are swiveling and rear wheels are fixed, it follows that. But in case of chair, we require 5 legs swiveling, because it needs all different movements everywhere, it does not require a specific direction. So, that smooth rotation it is there. So, all these things we need to consider while designing. Now, another thing we can say that suppose in this there are some activity areas. In this activity areas we can say that now the work here is being done with a normal sweeping hand movement. So, it is as per, and then movement is in front. Now, if we see the another work area of this type of activities, the frontal movement, is like now see, if he wishes to work sideways, then it will be difficult for him. So, the frontal work area, so this is the normal body axis movement, one can beat like this way frontal. So, it goes along with the normal body axis movement. Now, the holding and operation with both hands. Now, see all the work activities shown here, it follows a normal movement, the way it is operating, the group is also operating in this. Now, if we see another thing is that here a grass cutting or de-weeding equipment, he is holding like this way and then he is holding, but his and movement he is moving front or side and the equipment is carried like this way. But in this case what happens, though he is moving, but while holding it, it gives a static load on the both arms. So, to assist it, there is a belt to hang from the back. Now, if we see this, the total movement, now here the person is moving, he is moving, but his arms are in a fixed position, it gives a static load. So, whether it is as per is normal body axis movement while holding, that is okay, that we need to study it. Now, another, in this case the force application and hands movement pattern and position. Now, we can see that the beating of this bell is as per normal movement, like this way it is being fixed. Now, handle holding position to be noticed here in this case, how he is operating, how he is going, and the leg paddle position, this is brake and etcetera position here, the how it is doing. It is not at the center, it is little away. So, even for the pedal operation also, it needs from the center of the body, it has to be around 15 to 30 degree away from that center line. So, that our normal pedaling operation can be done. Now, here the same thing, the pedaling at normal leg and foot movement. This is the ranges of this movement, as we said earlier, the total movement of the foot, it should be within the normal movement range. Now, while the car making, the different car holding positions are shown here, and it says that whether to operate these various operations, whether it is within their range, like this, while getting up or going inside, like that, what is the normal movement, whether it is within their normal range of body angle movements, etcetera. Like this, the reach values and etcetera. Now, while holding, etcetera, like that way. This type of studies are being carried out with an example, just I am showing here to get acquainted with the theory portions. Now, in summary, it can be concluded what we discussed today is that, as at the beginning we said it also, now we are repeating it. If any movement or force to be applied either using a part or the whole article, the direction for force application should go with the configuration of the human body, that is, it should synchronize with the human natural movement axis, so that maximum mechanical advantage could be achieved. Now, with this we are concluding today's session, and next class, that is the class number 16, we would concentrate on posture and job relation. So, till then, thank you very much. We will see you next class. Thank you.